If you are watching this video, that means you have already tried learning DSA from big names, you name it. But let's be real, most of us still forgot those concepts after a week or a month. So after watching this video, I bet you won't need to watch any other tutorial because I have covered almost everything. You can check the code in my GitHub profile and don't forget to join the Telegram channel for more updates. So let's get into our video. Hello everyone, in this video we are going to detect cycles in a graph, both in directed and undirected. But before that, let's see today's insight. You can solve 60% of the problems if you can just dry run and understand the test cases. Whatever might be the problem, just write down the test cases on your paper and try to solve them and figure out the solution. By doing that, you can solve 60% of the problems right there. I'm not just saying this because even I have done that and I have figured out the solutions of many problems. So from now, whenever you come across a problem, just try to put it on paper and try to figure out the solution. So before getting into the actual question, let's understand what actually a cycle is. It means by observing this graph, we can see there is a cycle present here, right? But this is not the actual definition. If you are able to reach any node of the graph, starting with the same node and ending with the same node. So like in this graph, we can see if we start with node 1, we are able to reach the same node again, right? Some of you might also say that then this is also cyclic, but this is not the case like that, because for a graph to be cyclic, we need at least 3 edges. So this is what actual cycle is. This is not a cycle. We have only one edge here. Now we have understood what is cycle. Now let's try to detect it. So let's take this example 1 and try to do a DFS traversal on this graph. This is the adjacency list of this graph. So let's start with DFS traversal. If we start with node 1, we'll mark this node 1 as visited. We'll travel to node 2. We'll mark this node 2 as visited and we'll go to node 3 and we'll mark this 3 as visited and we'll go to node 4 and we'll mark this 4 as visited. So we can observe something here, right? We have reached to a node where all the connected nodes for this particular node, all these are visited. So I think, so we have figured out something from here. If you are able to get any node such that all the nodes are visited, and then we can say there is a cycle present here. Let's take another example where there is no cycle and let's see whether this intuition works or not. So we'll start with node 1 and we'll travel to node 2. We'll mark this 1 and 2 as visited and we'll move to node 3. We'll mark this 3 as visited and we'll move to 4 and we'll mark this 4 as visited. So even in this case, we can see that for node 4, we have only node 3 as connected and it is visited. If you go with the above intuition, then we need to say there is a cycle present here, but there is no cycle here. Our intuition fails here. We have got into a situation where in both the cases, there is a similar thing, that is all the nodes are visited, but in this case we are getting there is no cycle and in this case we are getting there is a cycle. So what is the key difference between these two? In order for this graph to be cycle and this graph to not be a cycle. So if we take these two nodes, so what we can observe from this both cases is we see node 3 is parent and even in this case we see node 3 is parent, but there is another node which is not a parent and we see that node is visited. Of course, right? This is the only difference that we can see from this both the cases. So we got a much more improved case, right, from our previous intuition. So let's see whether this intuition works with the other examples or not. Let's check our intuition with this example 3. We start with node 1 and we'll go to 2. We'll mark this 1 as visited, 2 as visited. We'll move to node 3. We'll mark this 3 as visited. We'll go to 4. We'll mark this 4 as visited and then we'll go to node 5 and we'll mark this 5 as visited. And there are no other nodes which are connected to 5 which are not visited. So we'll go backtrack to 4 and we'll move to node 6 and we'll mark this node 6 as visited. So for 6, what are the connected nodes? 1 and 4, in which 4 is parent of 6. 4 is the parent node. And we have got another node which is not parent, but that node is visited. So from above we said, if we can get any case like this, then there is a cycle present. And we can see there is a cycle present here. So I think we have figured out the solution, right? This is the final intuition. From all these 3 examples, we can say that if you can get any node such that it is visited, but it is not parent, then we can say there is a cycle here. So see how we figured out the solution of this question just by writing the test cases and building upon each approach. So we just started with understanding what is a cycle, and then we have started with example 1, and we have got an approach here. Approach 1 where all the nodes are visited, then we said there is a cycle. And then we got another example which contradicts the above example. Both the cases are same, but there is cycle and there is no cycle here. So we tried to figure out something from these two cases, and we got something like there is 3 which is parent, and we got a node such that it is visited and it is not parent. So this is how we figure out the solution of this question, just by writing the test cases and understanding what is happening, what the similarities and differences between each cases. So that's it. So we have understood how to detect cycle in an undirected graph. So let's try to write pseudocode for this. We'll call a function with adjacency list, visited and current index. So first we'll mark the current index as visited, and then we'll travel neighbors. So here we can get 3 cases. So first case is if it is not visited. In the second case, if it is visited and parent, and in the third case, it is visited and not parent. So in the first case, if it is not visited, we'll directly call DFS for the neighbor. And if this returns true, then we directly return there is a cycle. And in this case too, if it is visited and it is parent, then we just simply continue. And in the third case, if it is visited and it's not parent, which is our required case, then we'll return true. And at the end, we'll return 0. So this is as simple as it is. Whatever we figured out, we tried to write it down step by step, and this is the actual final code. Thank you for listening. You can check the code in the description, and we'll try to do it with BFS in the next video.